In this video, we're going to look at some basic percent problems that you should be able to work, and if you don't, hopefully you will by the time you are through with this particular video. So these deal with, again, problems involving percent. So we'll look at the first one. So let's look at the first one. We have 35%. We're dealing with this particular rate here, 35%. And you should be aware that the percent sign means per 100. So I could actually write this as 35 times. Instead of the percent sign, I could just write 1 over 100. If I multiply this out, I get 35 divided by 100. And if I divide this out using long division or using a calculator, this is going to give me 0.35. So normally when you're working with a problem that involves a percent, you usually convert the percent to a regular decimal. And you can easily do that by just, like I said, in this case, you just move the decimal over 2 places. So instead of 35%, it becomes 0.35. Now going the other way, if I have 0.0257, and say I want to convert this to a percent, then I could just do this and say, okay, this will be, just multiply by 1 over 100. But that changes the number. But if I multiply by 100 over here, and 1 over 100 over here, then those cancel out, so I'm just multiplying by 1. So it doesn't change it. So if I want to convert 0.057 to a percent, then I would simply multiply that 0.057 by 100, and that gives me 5.7. Moves the decimal over 2 places, and then this 1 over 100, I can use that as my percent sign. So it becomes 5.7. So that's why they tell you if you have a percent and you want to change it to a regular decimal without the percent sign, just drop the percent sign, move the decimal over 2 places to the left. Going back the other way, do the same thing, the opposite thing I should say. If you have a number and you want to convert it to a percent, move the decimal over 2 places to the right, and then add your percent sign. Gives you the same thing. So in this case, we're using basically the formula P is equal to B times R, where P is the number or the percentage you get if you take some base value and multiply it by R, which is your rate. And that's going to be your percent. So if you're given the base and the rate, multiply these out, and that gives you the percentage. That's your percentage. So what we're going to do is just take each of these and write it in the form of an equation. So I have 35% of, and the base always comes after the word of, and that's an implied multiplication. So in this case, I'm going to have then 35 will become 0.35. Always convert it to a regular decimal. What I did there was I dropped the percent sign and moved the decimal over 2 places to the left. So I want to know 35% of 120 is what number? So this would be, of means time, so I put a dot there, and then I would 120. The is, always think of that as the equals. So I multiply 0.35 times the 120, and I get 42. Okay, so in this case, this is kind of switched around. So the 42 is actually your percentage. The 0.35 is actually your rate, and the base is 120. So the answer to this one is 42. 35% of 120 is 42, or it's equal to 42. Now, let's look at the next one. 21 is, so let's write it this way. Again, all we're doing here is just basically plugging into this formula right here. So 21 is, so that's 21 is equal to what percent, okay, so that's your rate. I'm going to use an X, I could use an, oh, I'll go ahead and use an R, is what percent of 150. So it's actually in this format, not necessarily the same order. So the R, of course, is the unknown here. The base is given, 21 equals, so 21 actually is a percentage that we're looking for. What percent of, and the 150 is your base. So in this case then, I simply divide both sides by 150 here to solve for the rate. These cancel out. So the rate will be equal to 21 divided by 150. So take your calculator out, divide those out, and that gives me 0.14. Or, to write it as an actual rate, move the decimal over 2 places to the right at the percent sign. So 14%. And you can check that out. Multiply the 14% or 0.14 times the 150 and you get the 21. Okay, so they're all based on this particular equation right here. In some cases you're looking for the percentage. Sometimes you're interested in the base. Sometimes the actual rate. Clear this. Okay, so let's look at the next one. 2.5% of what number is 10? Okay, so the rate of the percent is 2.5%. So convert it to a regular decimal without the percent sign to be 0.025. Move the decimal 2 places to the right, or to the left, I should say. Drop the percent sign. Of, that's your times, what number? That'll be your base. You can use B. I'm going to use X. Doesn't really matter. It's just a variable. Is equal to 10. So 10 is the percentage, of course, and we're looking for the base. So solve this equation with X. Divide both sides by 0.025. So this would actually give me just X is equal to 10. Divided by 0.025. Take your calculator and divide this out. 10 divided by 0.025 is 400. And that's your answer. And you can double check that, multiplying the 0.025 times the 400 will give you the 10. Let's clear this. Yeah, we got a word problem here. Again, basically using the same formula. An item in a store has a selling price of $30.24. So that's what it sells for. If this includes a 20% discount, what was the original selling price? So it was discounted. So the holidays are coming. Maybe they discounted it for Christmas. So let X equal to the original price. So then what they're doing here is you're having, okay, the original price, and they want a discount. So you want to discount this by 20%. 20% is the same thing as 0.20, or you can just write it as 0.2. The 0 doesn't matter here because of the position. And this gives me 0.80. This is a 1 here, remember. So 1 minus the 0.20. This is x here. Okay. So we're subtracting 20% of the price to the original price. So this is going to be 0.80x. So basically this is another way of asking 80% of the number x. So I just write it 0.80x is or equals what you paid. This is 30.24. So now, solve for x and divide both sides by 0.80. So these cancel out here. So x will equal to 30.24 divided by 0.80 is 37.80. And that's dollars. Okay, so with the 20% discount, it comes out to 37 or 30.24. Okay, so the original price was 37.80, and with the discount, you pay 30.24. So another way you could write this without doing this part right here is you could just say, okay, the original price is being discounted 20%, so you're actually just paying 80%. So you could go from that to this part right here. But either way, the original selling price is 37.80. Number 5, an item in a store has a selling price of 98.90. If the markup for this item was 15%, what was the cost of the item? So x is equal to the original cost. So you paid $98.90 for it, but it was marked up. Okay, they wanted to make more money on it. What was the original cost, say, that they bought it for? So basically, what you have is you have x plus, and you're marking that up by 15% of what it costs. So it's 0.15x. So this is a 1 here. So this becomes in 1.15x. So the original cost is x, or 1x. And then they marked it up by 15% of that value. So this is 1 plus, or 1x plus 0.15x. That gives me 1.15x. So this is just saying 1.15. And remember, this is actually you can think of this as 115%. Okay? If you write this as a percent, that's 115 because of the markup. So you can just say then 115% is, of course, changed to a decimal. X is equal to 98.90. What's the original cost of the item? It was marked up by 15%, so they just divide both sides by 1.15 here. 1.15. 1.15. This cancels out. They'll come back over here then. So the original cost of the item is $86. So again, it's still set up based on that the formula P is equal to BR. Because all you're doing is taking the base times the percent. In this case, it's 115%. Equals to what value? In this case, the 98.90. So the original cost is $86. Thanks for watching. We'll see you next time.